Hey everyone, welcome back to the channel. Have you ever wondered how you can build a powerful language model that runs smoothly even on limited hardware? Today, I'm diving into exactly that. I'm going to share how to get 11th place in the Lelapa AI Buzuzumavi Challenge using a cutting-edge approach that blends QLoRA with completion-only supervised fine-tuning. This competition isn't just about ranking. It's on a mission to make African language models leaner and smarter, with a special focus on Swahili and Hausa. If you're working with low-resource languages or trying to deploy models in environments where computing power isn't endless, you're in the right place. In this notebook, I managed to hit a 0.11 leaderboard score on the machine translation task alone, and today I'm going to walk you through every step of that journey. Let's kick things off by talking about what makes this challenge so special. The Lelapa AI Buzuzumavi Challenge is all about pushing the limits of Incuba LM, a language model built specifically for African languages, by slashing its size and energy demands without losing performance on tasks like sentiment analysis, question answering, and, of course, machine translation. In a world where many open-source models stumble on African languages due to heavy resource needs and high energy consumption, this challenge is a vital push toward innovation and sustainability. It's all about empowering Africa with smarter, more efficient AI solutions. Today, I'll be focusing on the machine translation task that earned my ranking, though the techniques we're covering can be adapted to other tasks as well. So, let's get into it. We start by setting up our environment with all the necessary libraries. In my notebook, I begin by installing key packages. Think transformers for the base models, PEFT for parameter-efficient fine-tuning, bits and bytes for quantization, and TRL for some really nifty training utilities. I'm working with the MT-train dataset provided by Lelapa, which pairs English sentences with their translations in Swahili or Hausa. The goal here is clear: fine-tune our model so it translates English into these African languages more effectively. Now, let's talk about QLoRA, short for Quantized Low-Rank Adaptation. This technique is a game-changer because it addresses the need to make models smaller and more resource-efficient. What we do is load Incuba LM in 4-bit precision instead of the usual 16-bit, which drastically cuts down on memory usage without a significant loss in quality. At the same time, we use LoRa adapters that focus only on key components of the model, so we're not retraining everything from scratch. This combination means we can fine-tune our model without needing a supercomputer, making it perfect for resource-constrained environments. The next trick in the bag is completion-only learning. When you're fine-tuning a language model for translation, a common issue is that the model wastes energy trying to learn both the input and the output. But really, we only care about the translation part. So, with completion-only learning, we set up our training so that the model focuses solely on generating the translation. We do this by defining a special marker in our training examples, something like response, and then we only calculate loss for the tokens that come after that marker. Imagine an example like, translate to Swahili. Input, the weather is nice today. Response, instead of predicting every word, the model zeroes in on just the translation. The model we built doesn't just meet the competition's goals. It's a practical solution for deploying AI in resource-constrained settings. By reducing the model's size through quantization and targeted fine-tuning, and by honing its translation capabilities with completion-only learning, we're creating tools that can really make a difference. That's the story behind my approach to making African language models both smaller and smarter. If you're interested in low-resource language modeling or want to see how to deploy efficient AI models in challenging environments, I hope you found this breakdown both useful and inspiring. I've dropped a link in the description to my complete notebook on Kaggle, so check that out if you want to dig deeper. If you enjoyed this video, go ahead and hit that like button, subscribe for more practical AI techniques, and leave a comment below with any questions or ideas for future videos. Until next time, keep experimenting, stay curious, and happy modeling. See you in the next video.